Hi students, my name is Ratnaprabha Patil. Today we will continue with your topic electrostatics, and we will start with the point electric potential due to point charge, a dipole and a system of charges, in which point C, which is electric potential due to system of charges. Before that, you have studied electric potential due to point charge, a dipole and the system of charges, that is point B in your syllabus, that is electric potential due to an electric dipole, along with its one problem. Now we will start with point C from your syllabus. Now you have studied first point, which is electric potential due to a point charge. Then you have studied electric potential due to an electric dipole. Means firstly you have studied for one charge, then for two charges, then we will study due to electric potential due to system of charges. Means if charges are more than 2, then what will be the electric potential? So as you can see in the figure that you can see in the figure that there are the charges, which is Q1, Q2, Q3 up to Qn, which are separated by distance R1, R2, R3 up to Rn from point P, which is given here. That is, consider a system of charges Q1, Q2 up to Qn at distances R1, R2 up to Rn respectively from point P. Now the potential V1 at point P due to the charge Q1 is, you have studied this equation in point A, that is electric potential due to an point charge, where we have calculated the value of potential, that is electric potential, which is equal to V1, which is equal to 1 upon 4 pi epsilon naught Q1 divided by R1. Similarly, we can find out the potential V1, V2, V3 up to Vn at point P due to the individual charges, which you can see in the figure Q2, Q3, Q4 or up to Qn, which is given by equation V2 is equal to 1 upon 4 pi epsilon naught Q2 divided by R2. Then V3 is equal to 1 upon 4 pi epsilon naught Q3 divided by R3 up to Vn, that is Vn is equal to 1 upon 4 pi epsilon naught Qn divided by Rn. As you have studied the superposition principle, where the potential V at point P due to system of charges is the algebraic sum of the potential due to individual charges. मतलब पॉइंट P पे जो पोटेंशियल होगा वो सारे चार्जेस का एडिशन होगा, मतलब पोटेंशियल ड्यू टू चार्ज Q1 प्लस potential due to charge Q2 plus potential due to charge Q3 plus up to potential due to charge Qn. Then you are knowing that is 1 upon 4 pi epsilon naught will be common. Then inside the bracket equation is Q1 divided by R1 plus Q2 divided by R2 plus Q3 divided by R3 up to Qn divided by Rn. So you can write potential V at point P due to system of charges is equal to V, which is equal to 1 upon 4 pi epsilon naught summation of I is equal to 1 to n Qi divided by Ri. For continuous charge distribution, summation should be replaced by integration. Okay, this is all about the point electric potential due to point charge, a dipole, and the system of charges, in which point C is electric potential due to the system of charges. Okay, now in your syllabus there is a 1.8.5 which is equipotential surfaces, which is dropped from your syllabus for the batch 2020-21. So we will start with the next point from your syllabus, which is electrical energy of 2-point charges and of a dipole in an electric field. Okay, these points which we will discuss right now, this we have discussed before also. What are that points? If two like charges are separated by infinite distance, their potential energy is 0. This you have studied and we have discussed before also. Now, no work has to done in moving one charge. As you are knowing that if two same or different charges are placed nearby, then there will be some work done. आपको क्या करना पड़ेगा? कुछ work करना पड़ेगा to remove or to take one charge apart from other. ओके, लेकिन अगर दोनों में से दोनों चार्ज Q1 और Q2 में ज़्यादा डिस्टेंस है और दे आर सेपरेटेड बाय इनफाइनाइट डिस्टेंस, देयर तो आपको कोई भी वर्क नहीं करना पड़ेगा टू मूव द चार्ज, राइट. बट व्हेन दे ब्रॉट क्लोजर टू वन अनदर, work has to done against the force of repulsion, right. Means if there are two same charges are placed nearby, so अगर आपको एक चार्ज Q1 प्लस Q1 को प्लस Q2 के पास आपको अगर लेके जाना है, both are having same charges, there will be the repulsion. तो अगर आप Q1 प्लस Q1 को प्लस Q2 के पास लेके जाना चाहो तो आपको क्या करना पड़ेगा? वर्क करना पड़ेगा अगेंस्ट द फोर्स ऑफ रिपल्शन. नेक्स्ट पॉइंट इज as electrostatic force is conservative, this work gets stored as the potential energy of two charges. मतलब potential energy क्या होगी? The electrostatic force which is conservative, this work gets stored in the as the potential energy of two charges. So electrostatic potential energy क्या है? Electrostatic potential energy of a system of point charges is defined as the total amount of work done to assemble the system of charges by bringing the from infinity to their present लोकेशन. मतलब आप कोई भी चार्ज है उसको प्लस Q1 चार्ज को आप प्लस Q2 चार्ज के पास लेके जा रहे हो फ्रॉम इन्फिनिटी टू सम फाइनाइट डिस्टेंस, सो देयर विल बी द फोर्स ऑफ रिपल्शन. तो वो दो चार्जेस कुछ डिस्टेंस सेपरेट रहेंगे ड्यू टू फोर्स ऑफ रिपल्शन. दैट इज कॉल्ड एज असेंबलेंस. मतलब दोनों में कुछ गैप रहेगा. Okay, the total amount of work done to assemble the system of charges by bringing the charge from infinity to their present location, and this is called as potential energy of that system. Now we will start with the potential energy of system of 2-point charges. For that, what we have considered, there are two charges which is Q1 and Q2. You can see in the figure also, with position vector R1 and R2 relative to some origin O. तो आपको यहाँ पे क्या दिख रहा है, एक XYZ एक्सिस, in that वो उसका origin है. We have took two charges Q1 at point A, Q2 at point B, which is separated by distance R1, 2, and Q2 charge O, point O और origin से कितना दूर है और separated by position vector R1, and Q2 charge is separated by position vector R2 from origin or from point O. So in bringing आपको क्या करना है, एक चार्ज दूसरे के पास लेके जाना है. So for this, what we are going to consider, to calculate the electric potential energy of two charge system, what we are going to consider, that the two charges Q1 and Q2 are initially at infinity, and then we will determine the work done in bringing the charges to the given location by external force or agency, you can say. Okay, so पहले हम क्या consider करेंगे, that Q1 and Q2, these two charges are separated by infinity distance, or they are at infinity. From the infinity we are bringing that charges at the location which you can see at the present in the figure, that is A, B, which are separated by distance R1 from point O and R2 from point O. Okay, now what we are going to do, one sec. Okay, in bringing the first charge Q1 to position A, that is vector, its position vector is R1, no work is done because charge Q2 is at infinity. पहले क्या हमने कंसिडर किया, Q1 और Q2 दोनों infinity पे present है from point O also and from each other, मतलब Q1 Q2 भी एक दूसरे से infinity पे है, और पॉइंट O जहाँ पे ओरिजिन है वहाँ से भी वो दोनों क्या है, इन्फिनिटी पे है. तो पहले हमने क्या किया, A पॉइंट पे जो चार्ज है Q1, उसको हमने क्या किया, R1 जो डिस्टेंस है फ्रॉम पॉइंट O वहाँ तक हम उसे लेके आए. बट देर इज नो अनदर चार्ज, क्योंकि Q2 अभी भी इन्फिनिटी पे है, तो वर्क डन क्या होगा, 0. तो चार्ज Q1 को R1 डिस्टेंस तक लाने के लिए और R1 पोजीशन वेक्टर तक लाने के लिए, और यू कैन से जो डिस्टेंस है OA जो R1 पोजीशन वेक्टर है वहाँ तक लाने के लिए वर्क कितना करना पड़ा आपको, 0, बिकॉज देयर इज अ नो अदर चार्ज present at finite distance, right? So W1 is equal to 0. Now potential produced by charge q1 in space is, तो यह आपने पहले स्टडी किया है, देन v1 इज इक्वल टू 1/4 pi epsilon naught q1 डिवाइडेड बाय r1। नाउ अभी आपको क्या करना है, जो q2 चार्ज है उसको पॉइंट B तक लेके आना है। ओके, व्हेन वी ब्रिंग चार्ज q2 फ्रॉम इंफिनिटी टू पोजीशन B, दैट इज उसका पोजीशन वेक्टर क्या है r2 at distance r12 from q1, वर्क डन इज, तो उसका वर्क डन क्या बनेगा, पोटेंशियल एट B ड्यू टू चार्ज q1 इनटू चार्ज q2। ये आपने पहले पढ़ा हुआ है, ये आप एक बार बुक में चेक कर सकते हो इक्वेशन। तो वर्क डन क्या बनेगा, W2 इज इक्वल टू q1 divided by 4 pi epsilon naught r12 into q2. Now this is the work done in bringing the two charge to their respective locations is stored as potential energy of the configuration of two charges. सो आपको पोटेंशियल एनर्जी का इक्वेशन क्या बना, U इज इक्वल टू 1/4 पाई इप्सिलॉन नॉट q1 q2 डिवाइडेड बाय r12। इसका मतलब क्या है, पहले आपने पोटेंशियल एनर्जी का डेफिनेशन पढ़ा, उसमें आपने क्या पढ़ा, दैट इज टोटल अमाउंट ऑफ वर्क डन टू असेंबल द सिस्टम ऑफ चार्जेस बाय ब्रिंगिंग देम फ्रॉम इन्फिनिटी टू देयर प्रेजेंट लोकेशन। तो आपने क्या किया, पहले दो चार्जेस कंसिडर किया विच इज एट इन्फिनिटी, पहले आप एक चार्ज को लेके आए एट फाइनाइट डिस्टेंस, वैसे ही दूसरे चार्ज को लेके आए। सो आपने एक क्या किया, सिस्टम जनरेट किया, दैट इज वी हैव असेंबल्ड द सिस्टम। सो अगर सिस्टम असेंबल हुआ तो बाय ब्रिंगिंग, सिस्टम असेंबल करने के लिए जितना भी वर्क आपको करना पड़ा, दैट विल बी द पोटेंशियल एनर्जी ऑफ दैट सिस्टम। सो U इज इक्वल टू 1/4 पाई इप्सिलॉन नॉट q1 q2 डिवाइडेड बाय r12 will be the potential energy of the system of 2 point charge.